Hey class, welcome to lesson 4.1. This is all about writing linear equations in slope-intercept form. You guys are familiar with this as you were already graphing it last unit. Remember, slope-intercept form is y equals mx plus b. Some key things, we are back after winter break, so here's some key details. First one, finals are either January 21st or 22nd, depending on your odd or even day. You need to be taking notes and doing homework for every lesson. This is somewhat obvious, but I know some people don't believe in this, so I'm just reminding of it now. January 15th, Friday, is the final day to turn in any missing work or complete any test retake, so I will not accept anything after January 15th. Wednesdays are now going to be work days, and anything that is a work day for Wednesday will be posted on Monday or Tuesday, so technically you'll have Monday, Tuesday, and Wednesday to work on 2 different lessons, or have work time. Our learning targets for today are that you can write equations in slope-intercept form, and you can solve some word problems. Please make sure you write both of these down, along with the title of 4.1 from the beginning, before you start these notes. Alright, some key concepts here. As we said earlier, slope-intercept form is when you have y equals mx plus b. Your slope is the m value, your y-intercept is the b value. Remember, your y-axis is the up and down one, that's where your b value is going to go. And your slope tells you left to right, is it increasing or decreasing? Alright, so now we're just going to write out some of these. Remember that our base equation here is y equals mx plus b, where this is slope and this is your y-intercept. So if you know the exact values, this actually becomes pretty easy. You simply just rewrite this as whatever it has for you. So this one says slope is -3 and y-intercept is 1/2. That would mean it would be my m is equal to -3, my b value is equal to 1/2. Therefore my equation would become y equals -3x plus 1/2. For the other one, my slope is 0, my y-intercept is -2, so I'd have y equals 0 times x minus 2. We know 0 times anything is 0, so you can just get rid of that, so this one is just y equals -2. I would suggest, if you haven't graphed a line in a little bit, go to Desmos and graph both of these so you remember what they look like. Alright, so now we're going to start from a graphed version and go to the slope-intercept form. Remember, you'll always want to start with your y-intercept, and then you'll want to figure out how many over and how many up. So first thing I would do if I was you guys is I would make your slope triangles and figure out, okay, this one has a run of 4 and a rise of 1, 2, 3, 4, 5, 6. Because it's going from -3 to 3, that's a change of 6, and it's going from 0 to 4, that's a 4. So that means this one here is a slope of 6 over 4, which is the same thing as 3 over 2. The y-intercept is at -3, so my equation would be y equals 3 over 2x minus 3. My next one, again, I'm making my slope triangle. How many down? I'm going down 3. I'm going over 4 again, so that means my slope here is going to be -3 over 4. So my overall equation, using my y-intercept of 2, would be y equals -3 over 4x plus 2. Just as a reminder, slope is always the change in y over the change in x, which is sometimes given as y2 minus y1 over x2 minus x1. Write that down if that helps you out in remembering this. Alright, then sometimes you are not going to have the slope given, instead you'll be given 2 points. So in this case you'll want to figure out the 2 points, and then you'll want to plug values in. So in this problem here, we notice that our change in x, going from -3 to 0, is a change of 3, and our change from 5 to -1 is going down 6. Well, -6 divided by 3 is just going to be -2. Okay. Then we're looking for our y-intercept. And this y-intercept here is -1 because we are given the value on this one. So we would have y equals -2x minus 1. Next one we could do a similar thing. So our change in x is 8 because it goes from 0 to 8. And our change in y is 0 because it goes from -5 to 5. So 0 divided by 8 is just 0, meaning that our meaning that our y-intercept here again shows a -5. So we would have y is equal to 0x minus 5. So our y value is just equal to -5 all the way across. Alright, this one's just an example, and this is going to walk through how do you find out some things, and you can plug things in. So sometimes you're going to be using, function format. We introduced that in previous chapters. So again, if we have our input is 0, our output is 10, that's actually going to create the point 0, 10. And if our input is 6 and our output is 34, that's going to create the point 6, 34. Now that we have 2 points, we simply find the slope. So we do change in y, so 34 minus 10 and 6 minus 0 to give us 24 over 6, which is just 4. So our slope is 4. Now our y-intercept, again, if we have the value of 0, -10, anything that has x as a 0 is a y-intercept, therefore our y-intercept is just 10, so we just plug in the 10 here, and we're given this entire equation. Remember that you can substitute function and y in and out for each other, so in this case it asks for the function, so you have to make sure you give the answer as a function. So linear models are ways to just model real-life things using slope and y-intercept. That's the idea of this, is that we are building linear models as we move forward. So this one talks about a situation. This talks about how much energy is created in 2007 and how much is going to be built and used by 2012, and then also checking at 2017. So in this case, because we start at 2007, we're going to take that as our 0 value. And 2012 is 5 years after it, that's why the x value is 5 for that one. So if we had our 2 points, we can now make our 2 points as we start at 105 million. Now, we're not going to include all those zeros, we're just going to use 105. And then in 5 years, it's going to go up to 219, as it said in the word problem. The initial value of that y-intercept is what we started at. So our slope, we use these 2 points to help us find that. y2 minus y1, x2 minus x1, and we're given 114 over 5, which is equal to 22.8. We use both those ideas, so we have our initial value and we have our rate of change here, and we're given this. Now 2017 is 10 years after 2007, so that's why we're plugging in a 10 into our x value. And this tells us that approximately 330 megawatt hours of electricity is generated in 2017. Alright, here's your guys' homework. Good luck. If you have any questions, let me know on Google Chat.